Well, this is going to be a very important experiment as far as second stage Dead Sea salt precipitate is concerned. I've got about 9 grams of it here, all annealed, and the purpose of the experiment is to assess claims that M-state materials have anti-gravity effects, or as claimed had interdimensional effects, that is, not all their mass is expressed in our dimension. So I've devised a home experiment which you could probably do, and I'm just doing it a little bit more detailed to answer any questions in anybody's minds about it. So how I'm going to conduct this experiment is I've gone down to a specialist bolt store and got a stainless steel nut and 2 bolts, and you'll see here that let's bring it a little bit closer, that the nut is quite a large nut. It's 4 times the size of a normal nut, and you can see if you've got the right size bolts they can screw out and make a cavity here. So my idea is to sandwich this material in between these 2 bolts and weigh the whole thing, heat the whole thing up, and then as it cools down then put it back on the scales and see if it's changed in weight since before it was heated up, and just as importantly observe the weight as it cools down. So that's the basics of the experiment. A few extra controls that I'm going to do is that I've got some argon here. This is argon that you use in the wine industry. You can buy that over the net like that. Again, you wouldn't have to do that at home. The purpose of this is to remove the question about oxidation, at least to some degree. So I'm going to put some argon in this bag, and I'll undo this in this bag. I shall put some or all of this M-state material in a smaller container and give that a shot of argon in there, and hopefully not blow the stuff everywhere, and open that all in the bag, put it inside here in an argon environment, seal it all up in an argon environment, and then put it into my little furnace. But I taped a bag inside the corner here, and then duct taped it all around. I cut a little slit in it, and I evacuated it with my my vacuum cleaner, and then I cut and sealed that up. And then I've cut a little slit in one side and a little slit in the other side. I can't remember where I exactly did it. And I blew the argon gas in there, and first of all let it drain across these 2 lined up, push what little oxygen was out the other end, purged it out, and then sealed that hole, and then began to blow the bag up a little bit and then seal it off. So I've got enough room to move in there now. So now I can put my hand in this end here and hopefully use my other bag through the bag to, I can unwind that. So now when I take that bolt out, it will be it will draw argon into that bolt, and likewise my little container that I've got the second stage precipitate in, it's already in argon. So I'll turn the video off to do this in case I make a mistake trying to go too fast, or maybe I can manage it. I did weigh it, it was 9.09 grams, but I will weigh it again because I may not get it all in here. So okay, here we go. Coming pretty close. Tap it down. I should have released the bolt a bit on the other side. Maybe I'll try and do that if I can do that without spilling it. Well, now, well, at least I think I'll have about 5 grams. Okay, let's screw that other bolt in. So that's the combined weight, 267.76. So here's my argon shrouded sample in a stainless steel bolt. I do have another similar one here, and that's going to be done up here, and what I've got sandwiched in between the end of it is a K thermocouple, and that will enable us to know what temperature it's at. I'm going to put them both in here together. This one will be the control, and so I'll have no alternative but to assume that whatever temperature that one gets to, that's what this one will be to. This one's obviously got very slight difference in that it's not done all the way home like this one, although I can open one end, I guess. And they'll both go into there. This does have an infrared, but it doesn't work on shiny surfaces very well, so that's the purpose of that. These will go into here. Argon shield, squirted that in here. Now, in both cases, the tin and this, as it heats up, then oxygen getting in is not going to be a problem. I don't believe it would be a problem anyway. You won't need to do this at home. I'm just going the extra mile. As it all expands, the argon's going to be regressing, and that will hold most of the oxygen out. In any case, any oxidation is not going to be of any consequence, I don't think. So all that will go together, the lid will be sealed on. Once they're at temperature, I'll bring them out here, and the sample will go onto the scales in this jar. Just have a surround around it just to stop any breeze, because they're going to be hot, and the control one will go in here. And again, whatever temperature this one is with the thermocouple, I'll have no alternative but to assume the other one's the same. Okay, if you want to know about the forge, you'll have to watch my video on the making of the forge and the furnace in my sword making video. So I'll just get all that loaded up. I'll give you a brief peek when it's all going. The hairdryer here is to pump air into it and get it to a nice hot temperature, and I'll take it up to just under 500 degrees. Okay, our temperature's gradually creeping up, just over 200 degrees C, and you can see I'm just in the furnace. Now I haven't turned on the heater yet on the blower. You can melt steel in here when you get the blower on. So what I'll do is I'll put some pieces of asbestos around here, just to, not so it gets hotter, but just so the heats are reasonably even. Try not to burn myself. I need to let those gases out anyway, so just throw a bit of asbestos around like this. Now this whole little furnace covering I've made, then around the edge here, I've got a bit of finger in it, that's special refractory, so this thing will hold together. And the bottom's got refractory as well, which is part of the forge, and I'll get the blower going in a moment. Just coming up to 350. It's really only been about 10 minutes, so it's all working very well. I may not even put the blower on. I don't think I'll need it. Coming up to 470 and still rising. Everything looks stable. Getting close to 515. My limit's 550 on this equipment, so I'll definitely be stopping before then. Just hoping it'll level out a little bit so I can leave it at temperature. If it keeps rising, I might just take some of the insulation off and let it, see if I can let it sit at, you know, like 10-15 minutes at a temperature. Alright, we're coming up to 550, so I'm going to have to turn this unit off because its limit's 550, which we're now over 1000 degrees Fahrenheit. So I'm going to have to pull it out, and it will be pretty even, the temperature. I just would have liked to have let it stabilise, but it looks like it's going to go over 550. Not that it's a huge concern, it just means I wouldn't know what the temperature was and I wouldn't know when to turn it back on. So I'm going to pull this out now and just get everything set up. marks on the scales: 267.57, 507.1, 267.48, 500, 267.40, 490, 267.37, 480, 267.28, 470, 267.17, 460, 267.0, 450, 266.84, 440, 266.60, 430, 266.4, 420, 266.05, 410, 265.64, 400, 264.97, 370, 263.62, 360, 260.20, 350, 255.75. You can see how the weight's going down there quite rapidly as it's cooling down. I'll get you back into the visual seat here. Well, this is the result of the first run. Nice white precipitate still, probably whiter. I ended up doing a second sample, which I'll go into a bit more later when we look at the results. I'll probably put the video of the actual taking of the results last because it's long and boring, but I'll put just enough in it. Now the second sample, which went through the same procedure except it didn't have an argon shield. Mind you, because I ended up doing multiple runs on the first sample that only had an argon shield for the first run, then it's dark. Like I just was totally shocked. Just as much shocked at this as I was the rest of the results, and the reason why I did that second sample, like it's pepper and salt really. So hopefully I'll have some ideas by the time I finish this video. So let's have a look at the graphs. Well, this is the result of the first run and why I ended up doing a second run really. You can see that once the temperature dropped down to around 350 to 300 degrees, then the red line, which is the proportion of the original sample, had dropped by 100%. In other words, it weighed less than 100% what it did previously. And a real anti-gravity effect, so I didn't really believe that. I also felt that there's a possibility that the scales were being affected by temperature. Now I did actually have a insulator on the tray table of the scales, but I think the original temperature is so high, like 500 degrees C, it's cooling down this way of course, and that it is actually making that insulator hot and transferring that heat to the scales themselves. So when I was tearing it occasionally, but when it got to here, then the temperature was up here again. It could have been the effect, but I was just suspicious of the scale, so I ran the whole thing again. That's what led me into the second run, and I raised the insulator up on little insulation posts, and I still got the same effect on the second run. And so I decided to be a lot more rigorous again in tearing the scales to make sure that wasn't happening, and still I had an effect. Now mind you, and it was around the same area, so this is minus 100
percent of the mass. Here it was just dropping down to 30% of the mass, and here down to 60% of the mass. So the more I teared it, the less it was a problem. And on the fourth run, then I didn't get that effect at all, like tearing quite frequently again. But again, it was a less of effect each time as well, which, you know, it's possible something was going on. So getting on to, I changed this. First of all, I haven't labelled this too correctly, but I decided to see what it looked like if I pulled out all the teared samples. And so apart from run 1, then this is not done on a proportional basis, but on the net mass or the net weight of the sample. You can see which runs are referred to. You could see that apart from the very first run where it was in contact directly with the bed, then it was always significant mass or significantly higher weight closer to when it was teared. So these were either immediately after the tear or the sample after that as well, particularly at high temperatures where it hadn't heated up the sample insulator, and also the temperatures changing very quickly. So time's not a factor. So I nevertheless decided to do the run again, so with a second sample, and on the second sample, this is the proportion of the original mass. You can see that then the most I got was 91.4, let's say, % of the original sample being expressed, and also that has to be in the light of the fact that the end weight of the sample is around 93 to 94% of the original mass, which I'll get into later. So this is a percentage of not the end mass, but of the original starting mass, which was less. This was just over 4 grams in this one compared to 6 in the others, which I may have a graph here, so I have here. So this is expressed, this is the net weight as opposed to proportion. And you can see that there is a bit of fluctuation at the high temperature, and again the temperature, I used a completely different isolating system on this, so that I'm confident that the scales were not being affected by temperature at all, and yet I was getting some kind of an effect, and also that the expressed weight or the observed weight was increasing with time. Again, it's from right to left because the temperature is dropping. I couldn't work out how to get the scales to express properly with the y and the x-axis, but so just bear in mind you're reading from right to left. So the mass did increase slightly. Explanations, well, either this is a gravity effect, however you might want to express that, or perhaps we've lost mass on the way up to the temperature genuinely by some kind of reaction, and as it's cooling down it's drawing oxygen into the sample and we've got some sort of oxidation process happening, and so the mass is then increasing again perhaps, or else this is some kind of gravity effect as has been touted. Anyway, looking into the reaction side of things, now if the sample is basically magnesium hydroxide, then heating it up to 500 plus degrees C, then from 350 degrees C we're going to get this reaction occurring where the magnesium hydroxide decomposes into magnesium oxide and water. Now of course as water vapour, and at those temperatures it will just find its way out of the sample according to standard pressure and temperature rules. So that could be a possibility. Let's investigate that. Well, the molar mass of magnesium hydroxide is 58, while magnesium is 40, the balance being made up of 18 being water. And the ratio of magnesium hydroxide to magnesium oxide, which would be in the resultant sample, is 0.69. So in other words, magnesium oxide is 69% of the original sample because the water's disappeared. However, when we look at our situation, we started off with 6¼ grams, they end up with 6.11, which is 98% of the original sample is still there. So we can't say that that this reaction has occurred, at least not in entirety. And this is backed up by our second sample, which we've got a very similar result. The second sample also contained some of the sample came from a different batch, so that could account for the difference here. So we couldn't all account for it. Let's work backwards and let's say that the difference in mass or weight from the beginning to the end in each case could be accounted for by the lost water. So in the first case, then that's 0.14 grams. So if we said 0.14 grams, then by the same ratios we can calculate what the magnesium oxide part was and also the magnesium hydroxide. And so when we calculate that through, we should say, well, we had 0.45 grams of magnesium hydroxide at the beginning, which leaves unaccounted for, when we take that off 6.25, unaccounted for 5.34 grams of some other substance, which of course could be stated was supposed was the M state target substance that we're investigating. And a similar sort of calculation can be performed on the second sample, saying that there's 2 and 2.4 grams that are unaccounted for in the sample. So overall, we could say that this was more of a situation in the second sample for the reasons already mentioned, but a significant amount unaccounted material. I'm waiting for a higher temperature thermocouple, which will enable me to take it above 1000 degrees C to see what happens along those lines. In the meantime, with my salt and pepper samples, the light and the dark one, its M state is not supposed to dissolve in acid in the powder form, so maybe that's my next protocol.
335 250.00, 330 248.00, 320 244.60, 310 242.00, 300 239.79.
Get both these things in the field at the same time.
Two 264.81, 250 264.40, 240 264.21, 267.57, 516.2, 267.55, 460 267.53, 440 267.47, 430 267.43, 420 267.33, 410 267.19, 400 267.05, 390 266.9,
380 266.74, 370 266.57, 360 266.40, 320, 267.1. 310, 266.9. 300, 290, 266.52. 280, 266.31. 270, 266.06. 260, 265.85. 250, 265.66. 267.63, first reading. Still over 550 in here. $267.62. Still over 550 in there. 267.6. 530 here. 515, 267.61. 510, 267.6. 490, 267.58. $330. Seems to have worked. All right. Read differently at different temperatures. temperature. The numbers talk for themselves, imitating the temperature. So I'll pick it